This one is, saya akan pakai colourful lah buck. Okay, this one is buck converters, okay? Buck converters.
I think I got the answer, doctor.
That is 10 millihenry, the capacitor is 10 microfarad. The current here, current output, we know it is time domain, but we know this is actually a DC current, right? The C should be DC current. Break DC current. You have to find the people. So one of your friends have find out the solution. Find one of the solution. The solution is, we know this is actually a lossless components, which is ideal.
I got
So
the
meaning
answer.
what?
It's either 2 or 0, right, doctor?
Yeah, should be what? What should be the relationship? The P out
Which is
is equals to P in. So from that, you know that P in is VD multiplied with I source, right? So right now VD is already known, 80 volt. So you need to find IS. P out also can be calculated because you have already know the values of your current output and your resistor values. So without doing any equations that you have already learned, then you can, okay. So this one is 80, sorry, this is not 80. Sorry, this one should be just use I square multiply with the resistor. So this one is 2 multiply with 10. So this one is 40 watt. So P in is equals to P out. So this one, your I source should be 40 watt over 80 volt. So this should be 0.5 amperes. Okay. That's why I say only 2 minutes you can get the solution without doing or deriving or using the equation, the complicated equation. It's a very basic. Okay. The basic principle that we use is actually the power cannot be destroyed. So anything, if the power output is 40 watt, so the power input should be 40 watt. Not large or no less. Okay. So because we assume this component is ideal case. So everything that the power input should be equals to the power output. So you can see here, what is your V out? If you calculate it from here, berapa V out? V out is I square, right? I multiply with R, so which is 20 volt. It stepped down from 80 volt, step down into 20 volt, right? So what, even though it is stepped down, because you want to maintain the power. P in is equal to P out, meaning that the current is actually reducing. Increasing. The IS here 0.5, but the current output is 2 amperes. Right? Because P in must equals to P out. So if you reduce the voltage, the current will go up. Okay? This is all applied for all power converters, inverters, DC-DC converters, buck boost or buck boost. All applied. Yeah, memang is actually a very basic principles. Okay? So, okay, right now we already know that from the P in and P out relationship, you can calculate your current source. To double check, you can if you can use some equation from we have already learned from the buck converters characteristic. Okay, so let's try to how to check, to double check it using the what we have already learned. Okay, so right now this is your IL, right? And this is your IS. And what is the relationship between IS and IL? IS is equals to IL when
Switch
the
is
switch is
closed.
off, right? It's off. So you can write down. Sorry. Okay. So meaning that IS is equal to IL when the switch is on, right? When the switch is on. So when the switch is on, diode is off. Meaning that IS is equals to, during only on state, D multiply with IL. Okay. Okay, so right now we don't know IL. Okay, so IL is already known. What is your IL average? Bila ke? IL average. What is your IL average for buck converters? For buck converter, what is your IL average? Yes, is equal to I out. The relationship, you know kat sini. IL, this is the current IL, and this is your I out. All the average current, we go to the I out. Because IC here, we only accept ripple. We only accept the ripple current. So right now, you know that IL is contains of two components, which is IL average plus the ripple I max I min, right? Ini, this one is your IL. Consisted of DC component, which is IL average, plus IC component, which is min max here. Which is this point to this point is actually your delta IL. Right? Betul? Is it correct? So, the capacitor will actually only accept this ripple, which is delta IL, and the DC component will go straight to I out. Okay, so right now your IL average is already known, which is I out, which is 2. So what is your duty cycle? Your duty cycle is V out over VD or V input. So right now your V out you can calculate, right? 2 amperes multiplied with 10. So this one is 20 volt, right? Over 80. So you should get 0.25. So if you substitute D and IL average, your D is 0.25 and your IL average is 2 amperes. You should get the same answer, 0.5 amperes. Okay? So this one IL average and this one is your I capacitor. Okay, clear? For buck converters. So this one, if you master these buck converters, then you have no problem understanding boost and buck boost converters. Because it's actually the same principle is applied. Okay. Boleh So, then macam mana nak buang ni? Oh, clear the canvas. Confirm. Okay. So right now, let's go to the boost converters. So boost converters, so you need to actually memorize, okay? Memorize the boost converter circuit. So boost converters, the source is right now connected with an inductors. And then the switch is right now is actually at this position. And then you have the diode. And then the same position for the capacitor and also the load. Okay. So actually, the first analysis is to obtain the delta IL, right? So delta IL on, macam mana delta IL on? So you need to look at the circuit when the switch is turned on, right? So when this circuit is turned on, this diode is off. So meaning that this node is 0 voltage. So meaning that from here you can calculate your delta IL on is straight VL over L multiply with T on, which is DT. Sama macam bar it's same with bar. So I don't want to repeat again how to obtain VL over L. Because we know, okay lah, saya cubalah. VL is VD, VD, bukan VL. VD minus V out, right? And then we know that VL is L didt. So this one is equal to VD. So VD over L is equal to change of IL, change over change of T. And we know that the change of T here is actually T on, right? And what is your T on is DT. So that's why lah. So you pindahkan ke sini, jadilah VD over L DT. Okay? Okay, Salama, okay? Sorry? Yes, this one when the switch is on. The diode will off. Sorry? Yes, reverse. Because when the switch is on, meaning that this common point here, this is 0, right? 0 voltage. So when this is on, so meaning that this node is also 0 voltage. So, and then this one is V out. So reverse. So that's why diode is on. Because V out is higher than 0. Okay? This one essentially I have explained in my YouTube, and you should actually watch that. This is actually last week. So I just want to maybe to re-explain again but in a very short. Okay. So next is actually when the switch is off. So what happened when the switch is off? So when the switch is off, so the current here from this inductor or supply, so will actually discharge and the diode will turn on. Okay. So meaning that this one, you will obtain delta IL during off state is equals to, so right now this node is actually VO, right? Because this one is VO, right? So same node. So you can write down your delta IL during off state is VD minus V out over L multiply with T off, which is 1 minus D. Okay. And then from that, you know already that the change of IL on, okay, modulus without sign must equals to the change of delta IL off. Okay, from here, from this relationship, you will obtain the input and output relationship of the boost converters, which is VD over 1 minus D. Okay. Buck converter pun sama kan? You are delta IL on and then delta IL off. Then from that you can obtain the output input relationship. For the boost converter pun same. You are starting with the delta IL on and delta IL off. Then delta IL on must equal to delta IL off. From that you can obtain this. VD is equal to 1 minus D. So meaning that when D is 0, apa dia? So your V out is equal to VD. And when D is equal to 1, because we know that duty cycle is 0 to 1, right? Maximum, minimum. So your V out should be infinity. This is theoretical. Meaning that kalau you letak, you input 1 volt, your duty cycle is 1. So it can step up to 1 kilovolt, 1 megavolt. But that one is not practical lah. Okay? Because memang in practical, how come that you from 1 volt, you boleh step up to 1 kilovolt? Impossible. Kalau even though you can step up to 1 kilovolt, the current of the output should be very, very minimum, maybe microamperes, which is not usable because not usable because P out is must equal to P in. If you increase the voltage, the current must become very, very slow, very, very small, milli or microamperes. Ada tak komponen ataupun you punya radio yang microampere? TV pun is actually milliamperes. So unusable. Okay. So this is theoretical. So if your D is 1, so your voltage output will be infinity. Okay. And then another is actually the determination of the L min. So the L min, so here is actually same. You need to have same, which is IL average plus delta IL over 2. And for I min is IL average minus same. It's actually the same equations. Okay, because the IL here, this inductor, it will actually charge mean from min to max and then going back to minimum. So this is your IL, same. So this one is T on and this one during T off. Okay, during T on, the inductor will be charged. So it charged from minimum to maximum. Okay, and then during off state, it will discharge from maximum to its minimum value again. Okay, so you have maximum and minimum, and same at the center, you will have the IL average. Sama je. Okay, the same thing. So this one, from here, from this peak to this peak is actually delta IL. So meaning that from this one to this one is your delta IL over 2. From this to this one is actually same, delta IL over 2. Sama je. Kan? That's why when if you understand buck converters, then no problem on the boost converters. But the problem is, what is your IL average? It's actually not same with the buck, because the location of the component is different. For the buck converters, your IL average is equal to I out, right? But right now, can you say that your IL average here is equal to I out? Boleh tak? This one yang kat sini is your IL. Tak boleh. This one you ada diode kat sini. You cannot say IL is I out. Tak boleh. Because you have diode here, ID. You tak boleh kata IL is equal to ID and equal to I out. Tak boleh. Cannot. So how to derive the IL? So what the information that you can get from this part? Yes. Here, your I source is equals to IL average. Kat sini kan? This one is your I source lah. Saya pakai notation different Sometimes I VD, kadang Vsauce. Let's use Vsauce lah Senang. Vsauce, VS. So IS source lah. So from here you can say that this is I source is equal to I average. Okay. So how to obtain I source? How to obtain I source? Macam mana nak dapat? Okay, so right now we know that IL average is I source. But how to obtain the I source? You go back yang tadi tu. The previous example. P in is equal to V out is V out square over R is equal to V source I source. So from here you can get I source. And if you get I source, then you obtain your IL average. Okay. Okay, so right now, the first is actually the relationship, V out and V in. The second one is on the L minimum, IL, and so on. The last part is what? What is the last part of the analysis? There are tiga je analysis in this DC converters. Yes, ripple factors, which is related to the how to obtain the capacitor value. Kan? Kita ada tiga je. We have only three. The relationship between V in and V out, and then the inductors values, okay, and then Imax, Imin, and then the last one is actually the capacitor, which is related to the ripple factors. So when you want to actually see the ripple factors punya equation, what usually we see is actually we need to go to the capacitor current waveform, right? Macam buck converter pun same, capacitor current waveform. So what is your capacitor current waveform? That is the problem lah that you need to know. Next week, I will give the assignment, the second assignment, which is related to the boost converters. So if you don't finish yet the first assignment, so you can actually, for the first assignment, you can already submit it because I have already turned on the submission link. Sebenarnya saya lagi suka yang version yang lama ni, Microsoft. So I just use iSource, iSource and iSource. Okay. So right now, you need to obtain what is your IC current waveform. Agak-agak, what is the IC current waveform? IC. So right now, this one is actually you need to derive from the I diode. I diode. But the I diode come from the IL. Okay. Mana nak buat? Adakah IL is equal to I diode? Is it IL is I diode? Macam mana? IL is not equals to I diode because of this switch. You have this switch at the middle of them. So when the switch is on, the diode, apa benda ni? Dia tak boleh lah. That is the problem. The internet connectivity. Yang online student ni okay ke? Ke dah lost? Okay.
No, doctor, we can see still.
Okay, thank you. Okay, when this the switch is on, so the diode is off, right? So meaning that the current during on state is 0. Okay, saya tuliskan ni. It's actually a 0. There is no current. Okay. But when the switch is off, okay, so the diode will turn on, right? And then meaning that your IL will flowing through the diode. So we know that IL is actually at on state is, nampak tak? Takut saya shock sendiri je. When during on state, the current of the inductor is charging, right? From minimum to maximum values. This one is actually during T on. And then during T off, the inductor will discharge. Again, back to its minimum values. Okay? So right now, the current of the inductors that go through the diode is this portion. So meaning that the current ID waveform is like this. Okay? So you have this one is Imax and this one is your IME. Boleh nampak? Because I diode is only equals to I diode. I diode is only equal to IL when during T off. So that's why you have this waveform. This is your I diode. Okay? And then the peak is actually your IL maximum. And this part is your IL minimum. Okay. So then, apa lagi? Sekarang from here, you know that your I diode is equals to IC plus I out. And we know that I out only is actually a DC current, right? V out over R. Betul? V out over R. So, from this I diode, so meaning that your I capacitor is I diode minus I out. Okay? So, resulting a waveform of you ada ni the same, but it's actually going lower, shifted. This magnitude is V out over R. And this one is your T on, which is equals to TT. Okay, dia tolak ke bawah sebab dia tolak you punya DC current kan. I diode contain DC current dan ripple. And then, so IC tu is actually tolak yang DC current lah. So that's why you ada. So this one is your I capacitor. Okay, so from that, then you can calculate the charge. Okay, here, the charge here, because we know that this charge is equal to CVC. Okay, or the charge is equal to C multiplied with V out. And if there is a change of charge, there must be a change of the volt out. So right now, your Q, you can calculate your Q. So your Q is actually the area, kan? The area, so this is actually a rectangular, so V out over R multiply with dt. Itu je lah. Dah dapat Q, then you can calculate your, if you are been given V out, delta V out, then you can calculate your capacitor. Itu saja. Okay. Actually, you can see the same equation we use. The basic equation is actually the same. The only difference is actually inside that. For example, the waveform here and so on. Okay. And then ripple factors. What is ripple factors? So it's actually must be in percentage. So it is actually a change of your it is actually your ripple voltage over your out. Okay. So this one kita panggil, this one we call R, which is ripple factors. There is no unit, okay? Sorry lah, kadang saya terpaksa zoom out, zoom in because dia punya keluasan tak betul. Yang saya cakap tadi, kalau ni penuh ni, penuh whiteboard. So as I said, this chapter is very easy chapter because the analysis contain only 3. Relationship and then IL, L-mean and the ripple factors. Tak ada masalah. If you understand buck converters, then there is no problem on the boost and also buck. Okay. Apa lagi Okay, any question? Example sempat kau nak buat? Tengok example dia. I think example pun very straightforward. Example. The assignment, we have actually already completed the final exam question for you. Laju. Actually, before Raya dah siap dah. Just give you one tip. So the assignment that I give you after this is related to your final exam. So please do it in a group or itulah, because I know that I want to what I call reduce the risk macam only one student are active in your group. Okay. So meaning that you need to do cooperative inside your team. Then I think from that discussion you will come up with a conclusion, and that conclusion you share between your team members. Okay, then you can answer the final exam question. If you didn't do the assignment, the second assignment, then totally your question number 2 will got 0 marks. Because that one, daripada question number 2, we have A, B, C, D. Banyak lah, ada tak ada 6 A, B, C, D ni. So, A, if you don't understand, if you don't do the assignment, the question number A, you will not able to do it. And then, kalau A tu is, your answer is wrong, is correct, then it will affect all. Okay? So, that is the risk. So, I want you to do the assignment, the second assignment, do the simulation. Do the simulation and also prove it by using calculation and also. Okay? Okay, and then mana Allah, saya share pula dah. Sebab saya tak buka. Saya ter-share pula dia punya. Isolated ke no isolated? No isolated. Tak sempat aku nak buat ni. Some part macam contohnya for example boost converter semua ni. Okay, boost converters So I hope you know some of part tu saya tak highlight kan, but you need to know. You need to know for example this waveform. Contohnya, okay, I only concentrate on the IL kan? This one. IL kan? Okay, IL. Saya only concentrate mana ni? I only concentrate on the waveform of IL, but I haven't yet actually tak concentrate buat sini. But this one you should know. Kan? What is VL? VL during turn on, what is VL is VS. Right? During turn off, your VL is VS minus V out. This is the waveform. Straight line. Yang ni kena tahu. Okay? Because for buck converter pun sama lah. Okay? Saya hanya concentrate on IL, but I maybe miss to explain about the VL. Yang ni pun memang we usually will ask the student on how to sketch the VL. So this one for the buck converters. So as you can see, for buck converters during turn on is VS minus V out, and during turn off is negative V out. Okay, so different For boost different. Okay, for boost when it is on is actually VS, but when it is off is VS minus V out. But this one, I think this is very simple. What you need to do is actually to memorize the circuit. That is the most important thing. You need to memorize the circuit, the location, the position of the inductors, okay, diode and so on. Okay, so CCM memang we always want the boost converter to be operated in CCM. Okay, this one yang ripple factors tu. So this one, oh this one yung design juga ni. Specify the duty ratio, switching frequency, size of the inductor and capacitor. So tak sempat nak buat ni. Okay. But I have maybe we'll share with you lah. Okay, the answer and the solution lah. I think saya dah buat dah ni solution. So just for you to verify you punya step and so on. Okay. So I think next week we will go for buck boost converters. Okay, for buck boost converters. I don't know, buck boost converter ni nak buat activity in class or not? Because actually the same. The analysis is actually the same. So I want you to do in maybe not in a group, maybe individual. So you try to get the relationship between V out and V input. We do in the class. Boleh? In our next. Okay. So actually the same analysis. We go for the on-off state and then IL, L min, and then ripple capacitors and so on. Okay. Okay, I think that's all for today from me. So okay, thank you very much.
Thank you, doctor.
Thank you, doctor.
Okay.